Good morning, students. Today we start with laser physics, a very interesting topic, widely used in these days, even in toys. When we purchase a toy, a laser light is used in that. So now, first of all, we start with the laser. What is that laser? And this word laser stands because this laser is an acronym. Acronym means short form. That is not a complete word. So now, what does this laser stands? So that consists of that L mean light, A amplification, S stimulated, E emission, R radiations. When we connect these words together, then we get laser stands for light amplification by stimulated emission of radiation. Mean light get amplified by stimulated emission. So now to understand the laser, first of all we have to understand these basic processes, that is absorption and emission, because laser, that is stimulated emission. And one very important thing about that laser is a self-amplified device. That is, if we want to amplify the signal, we require transistor, but laser is a only device which amplify light or signals itself. So how that? By stimulated emission. To understand that stimulated emission, first we start with the ionization. And to understand the ionization, first we go to the Bohr model. All of you studied. That is structure of an atom. Accepted structure is Bohr. According to that Bohr, an atom is consist of a positively charged nucleus, which consists proton, neutron. The charge on proton, that is positive, and on neutron, that is neutral. And around that nucleus, electrons, they are continuously revolving in a fixed orbit. These K, L, M, N, they are the orbits, and number of electrons occupied by these orbitals, they are given by the formula, that is 2n square. N is the number of the level, that is K, that is n is equal to 1, first energy level. When we substitute here n is equal to 1, then 1 square is 1, and then number of electron in case L is 2. Similarly, when we go to n is equal to 2, second energy level, then 2 2 is 4, 4 into 2, that is 8, mean here that is 8, in the next that is 18, then 2 are 32. And the number of neutron in an atom, in a single atom, that is equal to number of proton. If number of electron and proton, they are equal, then atom is a neutral as a whole. So now what is ionization? Ionization is the process by which ions are formed by gain or loss of an electron from an atom or molecule. As I told that atom is neutral, but if we give that atom an extra electron and that atom receive that electron, gain that electron, then charge that is developed on that atom is negative and known as anion. But if there is a loss of electron, if an electron is removed from that atom, from any cell, then it gain a charge that is positive and known as cation. So now, to remove an electron, to gain an electron, that atom that requires some energy which is provided from the outside, and that energy is also known as ionization potential. Ionization potential or ionization energy is the energy required to remove an electron from a neutral atom or ground state. So now, if we want to remove an electron from an atom, then the energy which is supplied to that atom that is equal to the difference of the energy levels. First of all, the electron which is removed from an atom, that is removed from the valence shell. Valence shell means in the last shell. If we want to remove an electron from the inner shell, more energy, that is larger energy is required. So easily an electron is removed from the valence shell, valence in outer shell. So now that is the ionization potential or ionization energy. Now come to the characteristics of laser. As I already told, laser light that is different from ordinary light, and it has some characteristics which are not there in the ordinary light. Here I am showing you the three type of light which are widely used. First, all of you familiar, sunlight. Sunlight, that is white light and contain multiple colors. The light coming from sun, that is like these waves coming from that sun received by earth. Second is LED, very familiar, all of you seen that LED. LED mean light emitting diode, monochromatic in nature, but emit light that is non-coherent, mean in any direction, But third, laser, that is monochromatic but coherent in nature. Now that word coherent, that's not there in the another two type, but here that is coherent, mean if you compare these three, then you have seen here that is the laser light, that is consist of rays which travel almost that of a same phase, that is in a wave. This part, that is crest, that is trough. All the waves, trough, that is fall on a, that is at same point, crest fall on a same point. So that is the difference. So now there are four main characteristics of a laser which differentiate it from ordinary source of light. They are, first is laser light is highly monochromatic. I am using here word highly because no device is 100% efficient, but when that efficiency is nearby 100, then we use that word highly. So here I am using that word highly, mean nearly equal to 100%. So now laser light is highly monochromatic, highly intense, highly coherent, highly directional in nature. Now we discuss one by one, and these four characteristics, they differentiate laser light from the ordinary light. Here we also compare the two types of the lights. First we pick that highly monochromatic. Monochromatic, Greek word, that is consist of two words, monos, which mean one, and chromos, mean color. So now if we see the dictionary meaning of that monochromatic, that is single color. Mean one of the most important characteristic of laser light, that is it consists of a single color, and color is the characteristic that is related to wavelength. Mean the wavelength consists in that laser light, that is only one. One mean the band of that wavelength, that is very narrow, only single color is there. The range of frequencies, that is small. But in sunlight, that band, if we talk about white light, that is the wavelength start from 400 nanometer and ends at 700 nanometer. But in case of laser, that band 400 to 700 nanometer, that is very narrow. That is only, that is 600 nanometer to 620 nanometer. That is the difference. A very small band is there, only a difference of 20, and here that is 400 to 700. Here I am showing you the monochromatic, that is only single color is there, and in the polychromatic, because sunlight is polychromatic, that is when passes through prism split into a white color. As I discussed, that is that 7 color 400 to 700, but that is particularly one. 600 nanometer red, that is near equal to 600 nanometer, so only one color. Passes through prism, that will give you only one color. Second very important characteristic, highly intense. Laser beam is highly intense as compared to the ordinary beam of light because we know intensity is directly proportional to the square of amplitude, and square of amplitude is the energy. So now in case of a laser, when laser light, that is due to emission of photon that comes out from that device, then intensity of that laser light is equal to Na whole square, that is n square a square. N is the number of photons which are emitted, that is 1 2 3 4, but as this n square a square mean? So now see the diagram. First we start with the one photon, and that one photon that compel one, and that give a 2 photon, they further compel 2. Always remember, 1 give you a 2, 1 give you a 2. We start from 1, I repeat, we start from 1, 1 give you a 2, 2 give you a 1 give you a 2, then we get 4. Now we have a 4, 1 compel another one, that is also give 2, this one again give you a 2, this one again give you a 2. So multiplication factor is 2n square. When n is 1, then we get 2. When n is 2, then square. So now then b square, that is 4. Then this n is 3, again square. Then 3 square is equal to 9, that is 18. And so get multiplied that way. I am showing you that way. 1 that give 2, 2 give you a 4, 4 give you 8, 8 give you a that 16, 16 give you a 32, and the number get multiplied, and at last we get the intensity, that is the intensity, that is get amplified. But in case of ordinary light, intensity is proportional to n square. Simple. If we have a one photon, then square of the amplitude, that is the intensity. No multiplication of the photons. As I already told, there is a multiplication, but here is no multiplication. So that is the pattern I have shown here, that is the ordinary light. So now you understand what is the difference. Now come to the third, highly coherent. Laser light is highly coherent because all the photon emitted, they are in same phase, or having the phase difference between them is 0. But that mean, it means if we have a 2 or more waves emitted by a source, then the crust of all fall on a crust of another, trough of all fall on a trough of other, like this way. This is the laser, emit light. So why it is travel in straight line? Because due to these photon, they are the crest, fall on a 1, and trough of all, that is fall on a 1 point. So that is, as I already show, if that happened, then we get that amplified. So but in case of ordinary, the photon, they are in any direction, no combination is there, that is the ordinary. Here I am showing you the diagram, coherent in the same line, but incoherent, that is they are in the direction of their own, that is a very important. And last characteristic is highly directional. Laser light is highly directional, very narrow, collimated ray having no divergence. It is so much powerful, that is, if it is possible, by an arrangement on the moon surface that reflects the laser light which is incident on it, laser light comes back from the moon surface with the same intensity, because divergence is 0. And if divergence is 0, then spreading is 0. Then we switch on light in a room, that light spreads, that is torch. Then we switch on torch, then light spreads. Why it spreads? Because divergence is higher. But we have a laser light, all of you plays with that laser pointer available in the market, and the light come from that is very narrow, divergence is 0. That is the characteristic. Thank you.